We already figured it.
Wait,
We're recording.
Okay, here we go. 3, 2, 1.
Hey guys, this is part 4 of Equilibrium. Shout out to Mr. Ruff.
Yeah, it's fine. Okay, I forgive you. There's so much
It's like 4 words.
All right. That was beautiful. Mr. Ruff, we miss you. We miss you.
I got the wrong folder for last.
Okay. Today, we need about 15 minutes to finish up these notes. Yeah, but there's one page I forgot to put on it. So, here, can you give one of these to everybody? Thank you. So, yes.
We can give Mr. Ruff as a chaperone for the April field.
That'd be awesome. This is still chapter, what? I don't know what chapter it is.
What?
Probably chapter 13. Okay. Yes.
First use of my hand while writing.
Did you have surgery?
No.
Oh, good.
It was great. At the urgent care, he was like, probably gonna need surgery, and it's really bad, but I'm not sure go talk to the professional. I did. And I got a new x-ray on a much better machine. And it was like, it's not dispensing out that you need surgery, but new information. There's 2 major breaks.
Ooh.
Instead of just the one break.
So now you're fully casted.
There's spider web damage throughout the entire bone. I
Ooh.
basically shattered it.
Tis unfortunate. All right. So, here we go. The final example. Let me zoom in a little bit. Le Chatelier. Involves lead 2 carbonate that sets up the following equilibrium in solution. Remember how we were doing KSP? Yes. So PbCO3 solid is in equilibrium with lead ions and carbonate ions. Yes? Yes? Remember how we were doing this the other day? Okay, good. In acid, the carbonate ions, right? So here are my carbonate ions. If I put those into an acid, oh, this should not be NM. That should be equilibrium. Fix that. I don't know what the heck happened there. It should be equilibrium. This H plus is going to become H2O by ripping off a oxygen from the CO3, which becomes carbon dioxide instead of carbonate. So this means in this situation, the lower the pH, the more CO3 plus 2 ions are removed. Let's think about what we just said here. The lower the pH. If I have a lower pH, it's more what? Acidic. Which means I have more H plus, right? Which means I'm removing more of those. So, in the first equation, causing the equilibrium to be shifted to the right. To the right. And therefore, increasing the solubility of the lead 2 carbonate. I was seriously convinced that you stole that out of my backpack. I was like,
That's funny.
we're leaving straight from Keene today to go to Costco. So, yeah.
Are you the hot dog?
Oh yeah, hot dog for dinner. For sure.
Giant sheet, like, I want that so bad. I'll pay.
I don't know if I'm gonna have the cooler. 8 and 6.
Do you know,
Right here, buddy.
we're supposed to, I think I'm going to read, but we could do a team reading.
What teachers?
I'm reading those.
Okay. Because they're in 2nd grade and kindergarten. So try to get Mrs. Price or Mr. Rickus.
Oh, it might be Price.
Okay.
Photographs of Bond.
Cool. Awesome. Well, Avi is in Mrs. Price. Tell her that her dad said hi, if he's here. Okay. All right, consider the dissociation of iron 3 hydroxide. Here's the equation. In which of the following pHs would you expect iron 3 hydroxide to be the most soluble? Which one can I immediately get rid of? Yeah, what does this mean to us, right? You know it's going to be one of the extremes, right? Yes? So the question is it lower pH or higher pH? Ella says low. Got to get low, 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 low. I'm not sure that's a school appropriate song, so I'll stop.
They played it like old
We watched Ocean 12, it's okay.
That's true. Yeah.
No, he said Ocean 12, yes.
Ooh, now I got a high. So, I'm saying most soluble, which means I want to shift it to the right, correct? Yes? So, if I want it to go to the right, I want there to be more, either more of this, correct? Or less of this. Yes? If I make it lower pH, what am I adding? I'm adding more what? H+, which will turn this into water, which will remove this, shifting it to the right. So that would be a low pH. Nice work. What is the solubility, KSP, of PbOH2 in a solution of pH 9? A solution with a pH 9 has a concentration of OH 1 times 10 negative fifth. Soon you'll know about POHs and all that stuff more. So step 1 would be what? Write your KSP. So KSP equals concentration of Pb plus 2 times OH minus to the what? Squared, right? Because I technically have 2 OHs, correct? Yes, so that's going to become a square. You guys okay with that? Okay. Do I have a KSP? I do. So I know that 1.2 times 10 to the negative 15th is equal to, I'm trying to figure out what's the solubility at PbOH2, pH. Do I know Pb? Do I know Pb? No, I don't. That's X. Do I know OH? Yes. So that is 1 times 10 to the negative fifth. So what do we have to do here? Just solve for X. Well, yes, this would be squared. I thought somebody would have it, but
I got it. No, it counts.
can't. I mean, if it's for audio purposes, it's for part of the class.
What are you on about?
You better be able to hear it on the thing.
Wait, where's the jar?
And that's the end.
Yes, I got 1.2 times 10 to the negative fifth. 1.2 times 10. Say Home Depot, yes.
Yes.
That would be incredible.
We should walk in all with calculators and just like walk around playing the music.
That would be amazing. All right, take a look at this. Here we go. More ice, ice, baby. All right. Carbon monoxide reacts with steam to produce carbon dioxide and hydrogen at 700 Kelvin. The equilibrium constant is 5.10. Calculate the equilibrium concentration of all species if 1 mole is mixed in 1 liter. 1 mole is mixed in 1 liter. What would be the first thing you guys think we should do on this? Write an equation. So I've got carbon monoxide. Let's do our R per se. I have CO, which is a gas, is reacting with what?
Hydrogen.
What?
Carbon monoxide reacts with steam.
H2O, which this is going to be a what? Gas, is in equilibrium with
Carbon dioxide and hydrogen.
CO2, which is a gas. And how am I going to write hydrogen? H2. H2, which is also a gas. So, I, initial. Do I have initial CO?
No.
I do. Concentrations of all species, if 1 mole of each component is mixed in a 1 liter flask, 1 mole divided by 1 liter is 1 molar. I got 1 molar, and I have 1 molar, and I have 1 molar, and I have 1 molar. Agreed? Change. What's my change?
It doesn't change at all.
It changes. How do I know? How am I going to figure out what the change is? It does. We talked about this yesterday. How do we know which way it shifts? What do I have to compare?
The K and Q.
Q and K.
Yeah.
Could I solve for Q? I sure could. Let's do it up here. We know that Q would equal parentheses partial pressure of CO2 times partial pressure of H2 products over parentheses partial pressure of CO times the partial pressure of H2O. By the way, if you didn't get your lab in, make sure you get that lab turned in. What are all of these pressures? It's going to be 1 times 1 over 1 times 1. Agreed? So Q equals 1. So that means that Q equals 1. What's K? K equals 5.1. I gave you K, correct? Which means Q is less than K, which is right. So it's going to shift to the right because Q is less than K, and that's right. So if it's shifting to the right, what am I going to have for my x here? Minus x, right? So I'm going to have minus x, minus x. If it's shifting to the right, it's going to be plus x, plus x. We good?
Yeah.
So does that make sense what you're doing with Q and K then? Good. Equilibrium is going to be 1 minus x, 1 minus x, 1 plus x, 1 plus x. Now I've got to write my K expression, right? So K is going to be 1 plus x squared, agreed, over 1 minus x squared. I should have just put K is 5.1 instead of just writing it. What am I going to want to do to both sides? Square root, right? Square root to the left, square root to the right. So what is the square root of 5.1?
This is cute now. It's like 5.
Square root of 5.1. 2.26 equals 1 plus x over 1 minus x. Agreed? Yes? We do a little bit of factoring action. So 2.26 minus 2.26x equals 1 plus x. Now I'm going to add my x, and then I'm going to eventually solve and get the x equals 0.387. We're not going to work that through. You guys know how to do math. X is 0.387 molar. That's not what it asked me for, though, right? What?
Nothing. We don't know that.
You guys know how to do that, okay? But it asks for the equilibrium concentrations of all species. So CO equals 1 minus 0.387. Agreed? Which is also going to equal H2O. Those are the same, yes? Which is going to equal, what is 1 minus 0.387? 0.613 molar. And then over here, my CO2 is going to equal H2, which is going to be 1 plus 0.387. So it's going to be both 1.387 molar. So remember, I solved for x, right? So these, it's 1 minus x. So 1 minus, I just plugged it in. Because at equilibrium, it's 1 minus x or 1 plus x. These two are the same. These two are the same.
And that's it.
That's it. So this is not hard, it's just steps. It's not hard, it's just steps. Equilibrium is actually a pretty easy chapter. This last one is probably the most important one the most important example I can give you. Because you'll see. Gaseous NaCl decomposes to form the gases NO and Cl2. Step 1. R. So NaCl gas decomposes to form NO gas plus Cl2 gas. Okay. At 35 degrees Celsius, I got a K. In an experiment where 1 mole of NaCl is placed in a 2-liter flask, what are the equilibrium concentrations? Initial. Yeah, probably should balance it. I got 2 here, 2 here, 2 there. That look better? That's actually super important because that's going to affect our eye. Going to affect our eye. Okay. So, do I know which way this is shifting? Yes, I do. What type of reaction is this? It's decomposition. So which way is it shifting? To the right. So this I is going to be what? Plus what? Oh, not plus, sorry. Oh, wait, hold on. Initial. Initial. We're not plussing anything. Calm down. Initial is what?
Oh, it's 1.5. It's 1 over 2.
0.5 molar, right? Because it's 1 divided by 2. So 1 divided by 2 is 0.5 molar. Do I have anything to start out with for my products before I start? 100. Change. I know it's going to be minus because I'm decomposing. Minus what? Minus 2x. Minus 2x. Why? Coefficient of 2. Don't forget that. Minus 2x, plus 2x, and plus x. Equilibrium. So I have 0.5 minus 2x. I don't need a positive. I have 2x and I have x. Let's set up our K expression. K equals concentration of 2NO squared, agreed? Times the concentration of Cl2.
Wait, why is it squared?
Because you always still raise it to the coefficient. And you know what? These should be parentheses. See, I almost lost a point.
Would you put a 2?
Yeah, would you put a 2 out in front then? Of the NO?
It's 2NO inside.
And then it's 2.
Oh, wait. No. It'd just be NO squared. Good call. It'd just be NO squared.
And do we notice the particle pressure just because it's a gas? Or is that something else?
It's a gas.
Okay, so that's why.
These are all gases.
That's why you have to do parentheses instead of the.
Well, actually, this is mole per liter. We're not dealing in ATM.
So would it be brackets?
It'd be brackets. I'm sorry.
No, I was just making sure.
Yes, guys, we are eating.
We're eating. No, and it would be 2. It would be 2. The 2 should be here. Because it's 2NO, you still raise it to the square.
Yeah, but like, I thought.
Oh my gosh.
That was how you determine,
Audrey, do you have your white out?
You like get rid of it?
No, the 2 stays. That's 2NO squared. Remember how we did our solubility? It was 2x squared. You keep the 2. So the 2 stays in there. It's 2NO squared times Cl2.
That doesn't make sense.
Yeah, that doesn't make sense.
Does that not create confusion then?
What do you mean?
What do you mean that's confusing?
Like, why would you just add the square if you're gonna keep the square on that side?
Hold on. I got a thing. Let me just pause.
Let them think, guys.
Let me pause before we have to change this again. That's not helping if you guys are quiet.
I got it.
Wow, this is really weird when you guys are really quiet.
Does he have it?
Over the concentration of NOCl
So is there a 2 or not?
squared.
Yes, I said.
Yeah, and
So
then
is there a 2?
inside. Because
There's,
yeah,
yes, there's not a 2 on the inside if there's a 2 on the outside.
because
Like
like
that was
that
already it.
2 NOCl, but you don't.
Wait, let's look at a past
Because you
problem.
turn the coefficient into the exponent.
I know that.
You don't leave it in like we.
I'm just I'm thinking.
Let him think.
Or
I'm
is
thinking.
it because the concentration is representative of the thing?
No, guys, this should be 2NO squared, and this should be 2NOCl squared.
We never did that before.
We did.
On the third one, on this one, we had 2AB, and we just put it on the outside.
No, we
didn't
put
it on the inside.
2x.
No, we didn't.
No, we didn't.
Not in the formula.
And then shouldn't Cl2 like
Right here. It's 2AG, but
I think either
we
way,
only
so
had
I-
it on the outside.
Because you're gonna have the 2 on the top and bottom. So
Yeah, because that would be 2.
You're right. You're right.
Oh my gosh, bro.
We're good. We're good, 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 good.
It's all good. Good thing we have
We're good.
Home Depot sign.
Here's what I was doing. I was skipping a step. I know exactly what I was doing.
Yeah.
You know,
Consult the
don't
Facebook
worry,
group.
that was all part of the.
We don't have to consult the Facebook group.
LinkedIn.
All right? It's a little embarrassing when most people consult the Facebook group, in all honesty, because usually it's like something really easy. Here's where I was. Here's where I, yeah, like this. Here's where I went wrong. 1.6 times 10 to the negative fifth equals, what am I going to put in for NO? 2x squared. That's where I was. I was just one step ahead.
Would it be negative 2x squared then?
Positive.
JK, wrong side.
2x squared times x. Do you see where my brain was thinking there?
Yeah.
Over 0.5 minus 2x, that whole thing has to be squared. So here is where this gets unfortunate. If you would solve this, you would have to do what? Quadratic formula. But in chemistry, here's the thing. Look at this k value. What would you say about this k value?
It's small.
It's small. This is called the 5% rule. Because this is small, which way is it essentially not going? K is super small, so I'm barely shifting which way? What? There's hardly any going to the right. Agreed? Which means, because K is so small, guess what this X can be turned into? 0. Because K is small, by changing this to 0, your answer will be within 5% of what it would be either way.
The X or the
The X, just the X. So it's going to be, instead of 0.5 minus 2x, it's just going to be 0.5. Just the one on the bottom. Just the one on the bottom. Don't change the ones on the top, because the one on the bottom is where the shifting is happening. So that means that 1.6 times 10 to the negative fifth equals 4x cubed over 0.5 squared. How much better is that math? So much better. So you will never have to do quadratic formula on the AP test. All right, they'll never make you do that. If you end up with a minus x on the bottom, it's probably going to be a small k that you can take the x to 0. Cool? Solve for x, and x ends up being 0.01 molar. X ends up being 0.01 molar. Now, I know everything. So, concentration of NaCl, well, let's do Cl2, that's the easiest one. Cl2 is just x, so that's 0.01 molar. NO is going to be double that, so that's going to be 0.02 molar, because now I'm subbing in. And then my NaCl, a little bit more math, that's going to be 0.5 minus 0.02, what is that, 0.4? But with sig digs, guess what? It's just 0.5 molar. Because if I have 0.5 minus 2 after the decimal, it's 1 after the decimal minus 2 after the decimal. Yes? Still rounds to 1 after the decimal. This x is going to 0, so it's just 0.5 molar. That's it. That's a chapter. That is a chapter.
I don't like it.